made our own design basically. We put in some specific features for the bigger wind turbine, the locally built turbine. Some features that we wanted to have in the past but couldn't really find. And we wanted to make a solution that's easy to use and not very complicated, but you have one box or one panel that you can put there, and you have all your functions you need, so you don't have to mess around with a lot of different controllers that are maybe not compatible. We wanted to have a modular solution that you can extend. For example, if you need more power for your charge controller, you could add several more transistors or MOSFETs to it to have a higher switching capacity. Yeah, it's the thing that we built is based on an Atmel microchip where we put some of our own code on. So it's a digital, of course. So the specifications for our charge controller. We have basically a PWM dump load control, which is a common thing. Even in the industry, you mostly have this kind of regulation technique. We added a deep discharge protection to the system that can basically save your batteries when the battery goes down. We heard it before in the panel that it's important to keep your batteries well charged, so you don't want to discharge them. So you have basically the function to cut off your loads when the voltage goes down too much. We wanted to have on our controller have a live basically data from the wind turbine. So we added a small LCD display that shows you live data at all the time. For example, at wind turbine speeds, RPM, and the power from the wind turbine, battery voltage, and all kind of parameters. That's a nice feature. If you want to look at your controller, you can see it at one glance what's the turbine doing, how much is it producing. And another big feature we wanted to add to this controller is the option to log data. So we put a small module for data logging that you can actually write a lot of different data that's measured by the control circuit. By the circuit of the charge controller, and that writes into an SD card, so you can look at performance over time afterwards. So what else did we do? We made the charge controller in the first version for 12, 24 and 48 volt systems, so you can use the same control circuit for all different kind of wind turbine system voltages for off-grid systems, and up to 60 amps dump load currents, which is for the first version, but it can be extended by adding more switching capacity on the MOSFETs. And we had the opinion that it's nice to have a changeable frequency for your pulse width modulation for the dump load, that you can adjust the frequency basically. Sometimes with common charge controllers in small off-grid systems, you can hear the humming noise from the switching. And if that's in the water tank, then it can resonate, and it can be quite loud. So we made the function that you can change this frequency to maybe another level where it doesn't resonate with your building structure. We added some charging modes that basically bulk charging, float charge, and equalization to keep your batteries healthy and maintain the high capacity. And we added another feature that we call the turbine overspeed shutdown, which is basically a safety feature. If your wind turbine spins too fast for some reason, or there's some disconnection or something, and you don't want it to overspeed, it will automatically short circuit your generator and break the wind turbine when the speed is going up too high. The RPM are going too high. So you see on these pictures the controller. We put it in a box just for the first time that we can test it on the field. And on the other picture you see the small screen that shows you nice data, real-time data from your wind turbine system. So what we did then, we took this charge controller and I traveled to Scotland, to Hugh Piggott, the man who designed the open source wind turbines that we are using. And I went to his place and we